All right, so we're gonna get started. Tonight we're talking about different programming paradigms. So what exactly is a programming paradigm? Technically, at least according to Wikipedia, it's a way to classify languages based off of the different features they have. But obviously, most languages can do more than one thing. They're good at more than one thing. So lots of languages fit into multiple different categories. So you can also take paradigms as a different way to approach a problem because some ways of approaching a problem are different than others. So there's different types of paradigms. I'm not going to cover all of these ones tonight, but in the imperative category, there's procedural and object-oriented, which I'm covering both of those, and then declarative. I'll be talking about functional and logical. The other two obviously have their uses out there, but I'm just not going to cover them tonight. Feel free to look into them if you feel like you might need them. So the first one is procedural programming. And this is, I guess, what I'd classify as like the normal way we do programs, how we learn to solve problems in 150 and 250, where it's where the programmer makes specific instructions on how the computer should be solving the problem. So they say add these numbers, subtract these numbers. Control flow you use for, if, while, things like that. And then data you store in variables, which are either global variables or scoped variables. And then a typical thing of procedural programs is they're very modular, and you break down things that are repetitive into functions. And then these functions can in turn change global data. They don't always return things. Sometimes you'll have a void function that just prints but changes data. So example, this is solving Fibonacci sequence for numbers of up to n in not recursively, just in an imperative program. So it just goes through, you have your variables of the first and second Fibonacci numbers you'll need to keep track of in an integer. N in this case is with the nth Fibonacci you're solving for. So then it just goes through a for loop up until, and it solves the problem. And then here's the same exact thing, just I put it in a function because in a procedural program you would likely put something like this in a function. It wouldn't just be in main because then you can only do it once unless you copy and paste it. So then another one, object-oriented. This is where the programmer defines how to solve the problem, that's supposed to say problem, within the state of the object. And then you have your attributes and methods, or the data and the functions are defined on the object. And these things, objects have an operator operate on themselves. Usually it's this, sometimes it's self, but then you can use that and you operate on your object. Quick example, you got a class with their first and last name, and then you would print it with their first name and last name with the this on it. This obviously has its uses mostly, or a lot of times this is used writing apps. You use object-oriented. I know Swift is object-oriented, C# is object-oriented, Java is object-oriented. So that's a common place to take a problem approach that way. And then obviously you can kind of combine some of these things where you'll take classes and then combine it with some procedural to make it wouldn't be a complete OO program, but it has aspects of both. So moving on now, this one is probably one most people haven't worked with, but functional programming. So in functional programming, functions are treated more as first-class citizens. You can pass them as arguments to functions. They can be treated a lot more like variables, even though they are still very much functions. But in this case, the programmer, instead of directly instructing the computer, here's how we are going to solve this problem, you would write functions that describe how it would be solved, but not specifics, which is kind of confusing, but it might make sense. Control flow is handled via recursion, and then in more functionally based programming languages, there's pattern matching in like Haskell or Lisp or Clojure. I think those are three that are commonly used for functional. I know Haskell, you use pattern matching. And then functions don't edit outside data. They don't change it in any way. If you like passed in an array and then that function is to return an array, it doesn't edit the array that you passed into the function. It deletes that array usually and then just makes a new one. So they have no side effects outside of themselves. So here's an example of that same problem I solved with procedural. This is, again, the Fibonacci sequence, but this time we're solving it via recursion. So we pass in our number, and then if it's not 0 or 1, then we just call Fibonacci on it again, and we keep going. Then this is an example of the Fibonacci sequence in Haskell. So here we're defining our Fibonacci function. Lines 2 and 3 there is an example of pattern matching. It checks if the integer is 0, it will return 0. If the integer is 1, it returns 1. Otherwise, if that integer that we've passed in is any other number, we call Fibonacci on the n-1 plus Fibonacci on the n-2. So again, functional has its uses, and you can obviously still kind of include some functional with some like procedural. But if you have only functional, that's typically referred to as like a purely functional problem. So, and then the last thing is logical, and this one is really weird because instead of telling the computer how to solve it directly, or more like defining what the problem is and how the computer goes about it, you kind of describe the situation around it, and then the computer just kind of figures it out. This very common logical programming language is Prolog, which I have a small example of on the next screen. So what you would do in logical is you describe relationships between different things. So you can define like friend, like John is a friend of Bob and Bill is a friend of Jim. And then you can take those relationships and do some more defining on those, or like if you know that Bob is a friend of John and John is a friend of Bill, then Bob and Jim might know each other. So this can be useful in like family tree type situations. Like you can describe just who like parents are, and then this person is like a grandparent if the person below is a parent, and then the person below that is also a parent. So a really good example of this is the logic behind the board game of Clue, if you've ever played that, where you get different clues throughout the problem or the game, and then if you put all of those into Prolog, Prolog is really good at solving this game. So you can put all of the clues into Prolog, and then you basically ask it questions like, who's the murderer? And then it can figure it out. It might be able to figure it out based off of everything you've put in. So here's a small example of how Prolog works. So the top 3 lines is what's called the knowledge base, and it defines that Bill is a friend of John, Susie is a friend of Frank, and John is a friend of Susie. And then lines 5 and 6 define who is friends. And the way Prolog works is without those lines, or if I only had one of those lines, if I would have checked who a friend of, like if Bill and John are friends, it would like, okay, backing up. So if I did this line on 8, that's where I'm asking it the question. That should be is friend, not just friend. But so John and then who. Who, since it has a capital letter, it is a variable. So what I'm basically asking for is who is a friend of John. And then it would go through and search my knowledge base and figure that out. But without lines 5 and 6, it wouldn't know that Bill is a friend of John, because in Prolog, relationships aren't like inversely compatible like that. So lines 5 and 6 just make it so that both of them are friends. And then it can solve problems like this. So like the Fibonacci sequence, obviously you wouldn't use logical programming for this, but me and Blake never finished this conversation. But at our ICPC qualifier a couple of weeks ago, there was a problem about like different characters who speak different languages, and you had to write a program to figure out who everybody could speak to. And if I'm remembering that problem right, Prolog would be a pretty good language to solve that in, because you can just write what languages people know and if they can speak each other, and it wouldn't require like a crazy graph to solve everything out. So it definitely has its uses. All right. Anybody got any questions? I know that was kind of like super short, but obviously if you are on YouTube, you can use the questions page or hop in the Discord. And I guess one thing I forgot to mention about functional programming, works a lot like how a math function would work. So you have like f of x equals 2x. You get one input typically, you do some stuff with it, and then you have one output. There's not usually cases where you would just have a function that prints. I mean, like you can, but so. But assuming there are no questions, we'll call it there for tonight. Yeah, spring break's not next week. We'll have a meeting next week. I don't know what it is yet, but we'll have one. Otherwise, have a good weekend.